Now, coming again, we've already worked on the sine, cosine, inverse. We worked on the tangent, cotangent, inverse. Now we're going to the secant, cosecant inverse, and the one that we use is secant. I'm going to go through the same process again, where what I'm looking to do is to draw a triangle that's associated with this, and then take the derivative. So, the first thing I'm going to do is say, well, this would rearrange as secant of y equals x. If I take the secant of each side of this, secant y, secant of inverse secant just goes away and I have x. So now I want to draw that triangle. Secant of y is x. Well, what's secant? Secant is 1 over cosine, which means since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And again, x, hypotenuse over adjacent. That allows me to have the ratio of x there. And again, using a squared plus b squared equals c squared, which we can morph into if we call this side a. We're doing this. We have that squared minus that squared, and then the square root of the whole thing, so because b squared is x squared minus 1. So that tells us the three sides of the triangle. And now I move on and I do the derivative again here. Derivative of secant. Well, the derivative of secant, for those of you who remember, is secant tangent. And then chain rule says dy dx. So the left side is very complicated. Fortunately, the right side is not. The right side derivative of x with respect to x is just 1. So dy dx, I'm going to divide through by secant, divide through by tangent. Which dividing through by secant means I'm going to have 1 over secant, which means I have cosine. And dividing through by tangent, well, I can write it as cosine over tangent y. I usually try to move things into cosine, sines, and tangents because those are the ones with which we're the most familiar. Those are the ones that SOHCAHTOA works and all that. So what is cosine? Cosine is adjacent over hypotenuse. What is tangent? Tangent is opposite over adjacent. This is the 4-story fraction. 4-story fraction, the first and the fourth stories multiply together and go on the top. Second and third multiply together and go on the bottom. So that one's different. Over here we had a squared minus u squared under a square root. Here we had a sum and no square root. Here we have a square root. Turns out it's the opposite direction, right? Because here we had a squared minus u squared. This is going to be u squared minus a squared. We've got the square root, and in addition we have another term out here. So that gives us another class of integrals that we can look to solve by using inverse secant. And again, I'm going to switch over to being u's here, and I'm going to put the general form, because this doesn't have to be 1. This could have been, anything squared. And what it turns out to be is du is du over u times the square root of u squared minus a squared. Where in this case a is just 1. And that integrates to, in the same way that inverse tangent does, 1 over whatever a might be, inverse secant of the ratio u over a. And again, let me do an example with that. So let's say I have the integral of, let's say 8 dx over x square root (4x squared minus 9). Now again, I don't have to get that form perfectly. I know that I can make substitutions. So I'm looking for something that's a function of x here and here, okay? I look at this and I say, well, I'm not worried about the 8. The 8's a constant. But I see this x outside the square root, and I say, well, that looks like that form. And so, what do I see here? I say, well, first of all, it's supposed to be u squared minus a squared, so that means u squared must be 4x squared. It means a squared must be 9. Tells me u is 2x, a is 3, du dx is 2, which tells me dx is du over 2. And now I'm ready to make all the substitutions that I may want to make. Okay, I rewrite this, I say, well, the 8, I'm not going to mess with that right now. Dx is du over 2. That 8's going to cancel that, and I'm going to be left with 4 there. In the bottom, though, I've got other things going on. I thought, well, what about x? I said u is 2x. So based on that, I need to know what x is. But I can find that out fairly easily, because if u equals 2x, I divide each side by 2, and I say u over 2 is equal to x. So this becomes u over 2. So it's a little bit of a twist there. But this is now of that form u squared minus a squared. And again, I got some work to do here as far as the constants, etc. I say, well, gee, this is 8 over 2, so that's 4. So I've got 4 du on the top. On the bottom, I want just a u there, so I really have a 1/2 there that I don't want. But think about this. This is, again, this is a 4-story fraction. Right? This is 8 over 2, and this is u and that over 2. And so I bring that 2 up to the top. It's going to be times 2. And on the bottom, I'm going to have u squared minus 3 squared. The 2 and the 4 then come completely out here, and I say, okay, well then that's just 8, and now it fits precisely the form that I have over there. And so I say, if I have that form, I've still got my 8, but then in addition I got 1 over a, and I've got an inverse secant of u over a, and u is 2x. So I have that, and I'm done. And just in the same way that the inverse cosine just did the same thing as inverse sine, and inverse cotangent did the same thing as inverse tangent, inverse cosecant did the same thing as inverse secant, other than the negative sign. And so we don't worry about that. The only 3 inverse functions that we worry about of regular trigonometric functions are inverse sine, inverse secant, and inverse tangent.